Water is important item to take care of in highways and in drainage in athletic fields, golf courses. Dempsey. I'm the emeritus professor of civil engineering at University of Illinois, Champaign-Urbana. Well, I got my BS degree in 1960 from the University of Illinois as an undergraduate. Then after working for Division of Highways for about 6 months, I went in the Army and served 2 years in the Army, served overseas in France, and then came back and started working for Division of Highways again. I said, well, I think I'll get a master's degree, and after I got the master's, I got a PhD. I ended up where I didn't think it would. That was a faculty member at the University of Illinois. Well, I taught geosynthetics, and I taught a course in soil mechanics for highway engineers, and I taught an airport facilities class. We were in TRB in 1982, at Transportation Research Board in Washington, D.C., and I met up with some Monsanto people, and they were walking around with this door map material. They were trying to figure out maybe there was some highway use for that. And I could see right away it was too tortuous for any water flow through the thing, but I said, if we could convert that into a different kind of a structure, there's might be a possibility, and I call it fin drains, because I was doing some geosynthetics works at the time, and I said, we could make this into maybe something for highway drainage. And so that's when they started developing the Commerce setup with their continuous injection molding using high-density polyethylene. And we started from there. So we started a relationship with Monsanto at that time, started in 1982. And we had a product ready for field work by 1984. We ran more tests than you can stick. We really worked hard for 2 years developing the flow characteristics, developing the design characteristics, how to fasten this stuff together, make it work, and how to insert it into the trench even. So there's a lot of effort. When the first project came in 1984, it was up on I-80 near Morris, Illinois, and we were in pretty good shape and ready to go. I mean, they went from a product, usually you go through a small test section. The first section they put in up on I-80 was about 6 or 7 miles long. So we went full strength. I thought it was really a solution to the pavement drainage problem, because you had a product that accepted the water all along the pavement structure, as well as infiltration of the shoulder joint, and you had a good outflow. If it was installed correctly, it performed very, very well. In fact, the faulting up on I-80 due to traffic on the Hydraway sections compared to the standard pipe and sand envelope drain was like a fraction. It was really different. And the performance, as soon as that dropper rate hit that pavement, that drain started. But we actually put tipping bucket outflow beaters on those outlets, and was actually able to determine just how fast it responded and how it responded. It's a performance product. A lot of people look at it from the standpoint, well, how's it look? Is there any clogging or whatnot? But if you got to look at the performance, and when I was looking at pavement performance, my Lord, it was functioning so much better than the system they were using. Was pathetic. Well, the nice thing about it, you could put the Hydraway in a 4-inch slot drain, and we would use the material we took out of the slot to backfill back into it. Whereas the pipe and envelope system used about an 8-inch wide trench. It had required to put the pipe in and then backfill it with sand. So there's a big, the cost of the product was a little bit more than the pipe, but by the time you got through with it, this was more competitive. Not all fin drains are the same, not by any means of imagination. Well, some of them don't have a compressive strength. If you look at some of those mesh type materials, if you put some pressure on there, they'll collapse. Some of them are polystyrene, I think, and they're difficult to work with. ADS came up with their elliptical pipe as a competitor. So we did start a field where everybody started moving that direction for the narrow trench installation. We did a large lysimeter study where we was comparing with some of the other products out there. We did in-plane flow, we did compressive strength characteristics, shear characteristics, long flume studies to see what the flow was for design of the outlets. What else? We did studies on this stuff for about 2 really serious years. And then after that, probably 2 or 3 more. You have to be able to have somebody to go take it from that stage to the manufacturer to the field. And the biggest problem we have is moving an idea from an idea to manufacturing to actually being used. And so you think everybody would want to do it. The founding, in 1988, I got pictures here. I put this around the entire foundation of this house. Hydraway around that circular drive that goes down here and then drains out into the ditch. I got Hydraway along my driveway. I put that in. I got some pictures here. I laid that flat rather than putting it in like this, and because I didn't have a trencher, and that's worked really well. And then 2 years ago, I put the concrete pavement on top of it. So it'll last 100 years easily, if more. I mean, it doesn't deteriorate. Like I say, I wouldn't build a house today with a basement without having this stuff on it. I really wouldn't. I think it's the best product out there.